So this thing is recording. The graph of cos x. How does it look like? The graph of cos x, crosses the x-axis at 1. The next point, it crosses the y-axis at 1, it crosses the x-axis at 90, and then it turns at -1, crosses the x-axis at 270, reaches point 1 at 360. I'm going to draw it shortly. Sharp. So this is how the graph of cos x looks like. Let me write it there, cos x. Then the graph of sin x is literally the graph of cos x, ne? But you just shifted 90 degrees to the right. Let me show you. I'm going to take this blue graph, ne? I'm going to duplicate it, look, ne? I want to duplicate it, look, and I'm going to shift it 90 units to the right. Look. See, it's going to be like this. This is the graph of sin x. So these two graphs you need to know by heart. That's it. You need to know these two graphs by heart. Now, there's certain things that you need to pay attention to as well. All forms of the sine, or rather sine function comes in this format. A cos function, A cos bx, again, where the A gives you an indication about the amplitude. What is the amplitude of a wave? It is the distance from here to there, not from there to there. No, the distance from there to there. Okay, that's the amplitude, or if you like, the distance from there to there. That is your amplitude. So if you have a 1 here in place of A, it tells you that the amplitude of that graph is 1. That is this a vertical distance, or this one, whichever one floats your boat. Are we together? So as an example, we will use cos x, ne? And then we do realize that we have a 1 there at the beginning there. So which means that the amplitude of cos x is 1. We can also check that in the diagram. Let's focus on the blue graph. Halfway through the diagram, today is 1 unit. Another way to look at it is to say from there to there is 1 unit. Are we together? Good people? Okay, we're all together. Sharp, sharp. So that's very important. The same applies for sine as well. Sine function is generally in this primary format, A sine bx as well. Okay, sharp. Now back to the sine, the cos x function. What if you had something like this minus cos x? Okay, versus cos minus x. I want to show you something quickly. I want to come back to those two graphs. If this is your Cartesian plane, and you've got a coordinate there, the coordinate is 2s to 3, ne? And they ask you to reflect this point through the x-axis. That would mean you're going to reflect it through this line. You're going to put a mirror on that line, the x-axis, the mirror facing up. It will then reflect something that looks like this, a point somewhere there. And then the coordinates of this point won't change except for the sign of the y coordinate. It will be negative. It is just the opposite of what it was before. Do you guys see the reason we have y as positive, as negative, sorry? Proper stuff. Sharp. So this is what happens when you reflect. When you reflect a point such that its new coordinates become, or rather its new coordinates become the same except for the y changes signs. Whether it moves from positive to negative or negative to positive, as long as everything else remains the same and the y sign changes, it means that you will have reflected the reflection through the x-axis. Now, consider the same point, this point. You reflect it through the y-axis. That is, you put a mirror on top of this line, the y-axis, facing this direction, the mirror. This would reflect a point somewhere there. And the coordinates of this point will remain the same, except for the x. The x will just change signs and become negative. It changes signs. Sharp. Now, if they tell you, so this proves the reflection through the y-axis. That's what happens when you reflect through the y-axis. The y coordinate doesn't change, but the x coordinate changes signs. So if a statement comes like this and says x, y, ne, and becomes minus x, y, this means that they reflected that point through the y-axis. Are we together? Sharp. So now we're going to go back to trigonometric functions. Remember that the blue graph that I've drawn here is the graph of cos x. And also emphasize that under this graph of cos x, the number in front of cos x is 1. Our a is 1, which gives an indication about the amplitude. Our amplitude would be 1. So what if we get something like minus cos x? So obviously the a there becomes minus 1. The number in front of cos x becomes minus 1. Now, how does that affect the amplitude? With the amplitude is like distance. Distance is always positive. You can't say that, oh, I traveled negative 5 kilometers today. It does not make sense. Distance is positive. So the amplitude of this graph, of the graph of minus cos x, is still 1. You always take the positive sign of what you have there. Always. If it's a 1, you know the amplitude is 1. If it's minus 1, you know that the amplitude is a 1. If this thing is minus 2, then you say that your amplitude is 2. If this thing is 2, your amplitude is also still 2. Now, let us look at this graph of this graph of minus cos x compared to cos x itself. Y equals cos x, ne? Okay? So y is equal to cos x, and we change it to y equals minus cos x. Now, do you see that the y, this is y, right? This is y. Y is cos x. See that the y has changed, it become a negative. So the y, cos x is y, ne? It changed, became a negative. So which means that it is a reflection through the x-axis. You know when you like reflect a point and then the y changes signs, it implies that you will have reflected through the x-axis. So therefore, this means that for you to move from cos x to minus cos x to minus cos x, it means that you would have reflected the graph of cos x through the x-axis. Let's show you the evidence there. So this is the graph of x cos x, the one you see in blue. Now I want to reflect it through the x-axis. The x-axis is this line here. The line that I've highlighted in orange. Let's highlight it in pink. Sharp. So if I put a mirror here, let's focus on this point over here. On this point. On this point. If I put a mirror there on the x-axis, ne? If I put a mirror there on the x-axis, facing up, ne? On this line, this line. If I put a mirror on this line, ne? Okay, on that line. Okay. Facing up. The mirror will reflect this point somewhere there. Do you guys agree with me? Somewhere there. Do you guys see that? Here. Yes, no? Let's talk. If I put a mirror, yes, on the origin line, it reflect something there. Yes, yes. So I'm gonna draw an X there. I'm gonna plot it. Okay. Now, uh, what about this point? Mirror facing up, the point reflects somewhere there. There. Since it is at 1, it's gonna be at negative 1 now. It's gonna be there. Then this point here reflected, it's gonna be somewhere there. X. Okay. Now, I've only highlighted these points at the top. Let me also highlight these points at the bottom. These ones, this one and that one. I want to put the mirror on top of the same line, but facing down. This point here will reflect there. So I'm going to put it there. And then this point will reflect there. I want to put a point there. And now these ones, these points, this point will just remain there. If you put a mirror there, just remain there. Those ones just remain. So therefore, a new graph will look something like this. Right? So we reflected the original graph of cos x through the x-axis to get the graph of minus cos x. Now, if they ask you to find the amplitude of this, you'll see that the amplitude is still 1. Regardless of this negative there, the amplitude does not change. You guys see that the negative sign does not affect the amplitude, but just tells you it's a reflection of the positive version of itself through the x-axis. Make sense? Hlophe, Shalom, Khatibe, alright. Nazo. Yes. Okay. Fede. So yeah, that's about that. And the last thing that I need to touch on. So the same applies when you deal with cos. You follow the sort of same procedure. Um, if they ask you to draw the graph of 2 cos x, what would you do? I'm gonna remove the graph of minus cos x so that we have clear space. Oh God. Oh, the grid disappeared. Oh yes, it's back. Okay. I'm trying to remove the orange one. Yes. Sharp. So now the graph we have now in front of us is still the graph of cos x. Now they want you to draw the graph of 2 cos x. 2 cos x. Okay. So now we know that this represents the amplitude. So how does it change? Remember that the original graph is y equals cos. Let's write it there at the bottom. It's y equals cos x. So what changed here is nothing but the amplitude. The amplitude moved from it being 1 to it being 2. So you're going to go to the graph of cos x. There it is. The amplitude here is 1. You guys can see it. So you're going to change it. You're going to make it 2. So which means that it'll be this point will be there. And then the amplitude here, as you can see, it's 1. Then you're going to stretch it for it to be a 2. The amplitude there is 1. You're going to stretch it for it to be 2. The amplitude here is 1. You stretch it for it to be a 2. Amplitude here is 1. That distance. You're going to stretch it and make it 2. So therefore, the new graph will be something, everything else remains the same. The new graph will be something like this. Nothing changed, but the amplitude changed. So this is the graph of y equals 2 cos x. Sharp. Let me save this video. Stay